So let's look at the sums of arithmetic series and see how we derive the formula for that. Let's say I ask you to find the sum of this series, 2, 4, 6, and 8. It's pretty simple. We could just add them across. Another way that we could look at this is we could take the partial sums. We could look at 2 and 8. What's the sum of that? Well, that's 10. What about 4 and 6? Oh, that's also 10. What a coincidence. We have two groups of 10. And that's going to be 20. Right, so what we did there is we found the partial sums and just multiplied them. Why was it 2? Well, when you have a group of 4 and you split them into 2, you're going to have two groups. Let's look at this next one here. 3, 7, 11, 15, 19, 23. What's the sum of that series? Well, again, let's take a look at our first and our last. That's going to be what? Yeah, you guessed it. 26. 7 and 19, again, that's 26. 11 and 15, again, 26. We have three groups of 26, which, when you put those together, that's going to be 78. Notice that in each case, when you add the first and the last, that's the same number you're getting in between. So there we got three groups. We had a 6-number set. We did 3 times 26 to find the sum. Now let's look here. How many pairs of numbers do we have in this 8-numbered set? Hopefully you're saying, well, if there's 8 numbers, there's 4 pairs. That'd be right. So let's look at 8 and 43. That is 51. 13 and 38. Yes, that is 51 as well. 18 and 20. Oops. That's 18 and 33. I'm a victim of my bad art there. There we go. 18 and 33, that's 51 as well, and 23 and 28, that's 51 as well. So we have an 8-numbered set, so we got 4 pairs, and we're going to multiply that by the partial sums, because we got 4 groups of 51, and that's going to be, let's see, 100, 200, that's going to be 204. It's a faster way to do it than just do 8 plus 13 plus 18. All right, now, what about these sets right here? Well, here we've got 3 and 9, well, that would be, what, 12? And then 6. We don't have a pair, I'm sorry, we don't have 2 pairs. We've got a pair and a half. So in this case, we took the partial sum being 12, 3 plus 9, and we're multiplying it by 1 and a half. We've got 1 and a half groups of 12, because we got 12 and then a 6, and that would be 18. So even with odd-numbered set, this partial sums things seems to work out pretty good. What about a 5-numbered set? Well, 5 and 9, that's going to be 14. And then we've got 6 and 8, also 14. And then we've got a half group of 14 with just 7. So in this case, we got 2 and a half groups of that partial sum, 14. 2 times 14 would be 28. Half of 14 is 7, so 28 plus 7. That gets us 35. Okay, so there's different ways that I've seen this formula, but I think for what we just did, the logic we built out, it's probably easiest to do it this way. So looking at what we did, we took the number of terms in each case. So in this case, we said, hey, there are 4 terms. Oops. And remember, we paired them up. So that's where the dividing by 2. We have 4 terms, but we paired them up. We said, hey, 2 and 8 together are 10. 4 and 6 together are 10. And then we did the multiplication. So their a sub 1 is the first term, and the a sub n is the last term, so that's where you get the 2 plus 8, which was what we did. Then you have the 2 times 10 and 20. That's how we got the answer to that. Now this might not seem that useful for a small set like this, but as we get up into much larger sequences, this is going to be very helpful. Okay, let's use the formula for this one. This one we had a 6-numbered set, so we divided 6 by 2. And then remember we did 3 times 20, or 3 plus 23, and we got 26. So 3 plus 23. And then 6 divided by 2 is 3. 3 times 26 gets us 78. So that's how we use the formula to help us find the sum of an arithmetic sequence. Now we're ready to go into some harder problems.